All right, now it's time, and I hope everyone is ready. So shall we get started? Good afternoon, everyone, and welcome back to Agoda Tech Talk. I am very excited because today we have a special guest and a special host as well. Abhi Nandan will be hosting the session today. So Abhi, please take it away.
Thank you, Nan. So, hello and welcome to today's session on scaling contract testing with Pact and Pactflow. Consumer-driven contract testing is becoming increasingly popular testing method in modern microservice design patterns. Although the concept and the practices of the CDC go back quite a while in the past, there are only a limited number of comprehensive tools available on this one. Pact is one of the most popular and robust framework in this area. Today, we are extremely delighted to have Matt Fellows among us. Matt is co-founder and currently principal product manager at Pactflow, now part of SmartBear. He's also a core contributor to the open source Pact framework. Thank you, Matt, for accepting our invite to Agoda's Tech Talk. We are thrilled to learn about Pact, Pactflow, and the significance of contract testing in the continuously changing landscape of technology and architecture. As for the session format, Matt would give us a presentation and a short demo on the topic, which will be followed by a Q&A session. So without further ado, over to you, Matt.
Awesome. Thanks, Arby. Thanks, Nan. Thanks for having me, everybody. Hopefully you can all hear me okay. Just get a bit of a thumbs up there from someone. Sound good? Okay, fantastic. And second check, you can all see my screen. Scaling contract testing with Pact. Yep, okay, happy days. Yeah, thanks for the lovely introduction. As I said, I'm one of the product managers here at SmartBear. We've recently been acquired. Pactflow has been recently acquired, as we'll briefly touch on. My background spans consulting, engineering management, cloud, APIs, DevOps, microservices, all of this. And I've been very lucky to have found myself in a situation where I've contributed to this open source project called Pact, and we've taken it from this small little thing into hopefully something that's changing the world. So today we're going to talk about what good looks like. So just stepping back a little bit, we're talking about microservices and testing here, but what actually does good look like in terms of numbers? We'll then look into the problem with end-to-end integration testing as your sole focus or your sole remedy for testing sort of large distributed systems. We'll then talk about how contract testing might be able to help you in that situation, how it works, and those benefits. We'll do a little demo, and hopefully there's plenty of time for Q&A there. So just a little bit about Pactflow. Really our vision is to create a world that doesn't care or worry about deployments. We want those things to be these no concern things you just do all the time. So we have a t-shirt that I'm not wearing that says it's okay to deploy on Fridays, right? Like back in the day, Fridays were like the sacrosanct day you would never deploy because you wanted to make sure your weekend, was not going to be impacted. But if that's not a world we want to live in, we want to be deploying all the time with impunity and not be worried about these sort of things. As I briefly mentioned before, Pactflow is now part of SmartBear. SmartBear is an amazing company, a large amount of services, and you can see here we've now featured our way into, part of this much larger testing suite here. And so hopefully over time we'll be able to provide, much more interesting services and better collaborations with some of these great tools that will really improve and get us towards that vision of making it easy for you guys to deploy. All right, so what does good look like? And kind of where are we at as an industry? I really like the DevOps report, the State of DevOps report from a company called Dora. I think they're now part of Google. But they each year release this fantastic report about DevOps and modern leading practices and the companies that are doing really well in the industry. And so there's actually now 5 key indicators, but there's 4 key indicators of high-performing organizations that really relate to what we're talking about. The first one of those we call lead time for change. So basically how long it takes you to go from a commit to a deploy. High-performing organizations do this 100 times faster than the low-performing. Similarly, they can deploy on demand. So they actually do about 200 times more deployments because of this. Now, you'd think with all that kind of change and how fast they're moving that they would actually break more things, the old Mark Zuckerberg, you move fast and break things. Well, actually, it turns out that in this sense, the faster you move, the less you break things. So these companies also have lower change failure rates relative to their peers, 7 times lower. And when they do break something, they can restore it literally thousands of times faster. So we're talking about lead time for change here, cycle times, the ability to deploy on demand, failure rates, and mean time to recovery. As it turns out, though, only 1 in 5 companies are in this kind of elite category, of course, because we're comparing companies. And there's lots of reasons for that. One of those reasons is teams spend a lot of time waiting for, managing, or fixing test environments. In fact, it's one of the biggest issues there is all similarly with test data. So both those things cause a huge amount of bottlenecks and delays in these processes, as we'll see in just a second. And there's other reasons there, of course, which we'll get into. So thinking about distributed systems, whether it's microservices or SOA or what have you, we need to make sure that they work together, right? When we deploy one of these new things into that ecosystem, we need to make sure that they work with their peers, those collaborating components. So there's lots of terminology in testing. Some of those terminology isn't very clear. But generally speaking, we're talking about integration testing here. Will these systems work with other systems? Now, the main thing that most companies do is they do what's called end-to-end integrated testing, where they put it all into one single environment and they make sure it all works together. We'll talk about that in a moment, but I think it's really good just to go to a customer quote we've had that I think really sums up the challenges and state of today's systems. You know, organizations are trying to deal with and grapple with moving to cloud, this DevOps movement, large microservice rollouts, heaps of different diverse technologies. It's challenging. So if you just look for this quote a little bit, you can see this company, large banking company, they have a very large program with lots of different teams. Think about 40 teams in just one part of the organization. You're building quite a large microservices event-based system. And they're finding it really difficult to test inside this volatile set of integrated environments. They're looking to get better confidence by doing more isolated testing, right? You know, the local or in environments in CI. But what they're finding is just it's really hard to do this when they've got RESTful services, GraphQL APIs, messages, third-party systems. They're just finding all this put together is just really hard to manage. And so it's this complexity that we're trying to find a way to deal with. And what most companies try and do is go, we're going to put more testing in place. We're going to put more processes in place. And again, the usual way that people do that is through what we call end-to-end testing. This gives us some semblance or some at least myth that we've got some control over the situation, right? But realistically, we're talking about what is emergently almost chaotic systems. Lots and lots of different people, lots and lots of different teams, systems, technologies, things that are outside of each of our control. When it all comes together, it's actually very hard to try and control that. So this is how they try and control it. We use tools like Postman or Selenium to do functional testing from the outside, right? We'll drive tests through a system, from the user interface, through the gateway, through services, and those messages will pass through the entire system, come back to the end user, in this case, the API client or testing client. And, if that passes, we're feeling really good. We're feeling like our system's all working together. The scenario worked. And if all those scenarios worked, we're feeling really confident that our system actually works because we've tested the real thing. But there's always a but. This kind of way of testing is quite hard to do well at scale. So the first problem is these kinds of tests are really slow. The bigger and bigger your system gets, the more and more tests you need. Generally speaking, exponentially more tests, and they take time to run. The second thing is they tend to be quite fragile. Again, because you're testing quite a large system, you've got different people, different teams deploying into this environment, trying to move at pace. But they're now having to try and come together. And what happens is you find the wrong version of software has been deployed, or the wrong test data has been deployed, the wrong test case has been applied to it, the environment configuration's out. All these little things can contribute to a flaky test in our end-to-end test environment. And furthermore, when it does fail, it's actually really hard to work out what went wrong, because now you have to log in to some logging platform somewhere to find out what happened. So for example, if the explosion happened in microservice B, well, whatever went wrong is probably hidden from the user. It's probably going to be buried in a log somewhere, because you're not going to expose that kind of implementation detail out to the world. So now you need to have debugging skills to look, production debugging skills to find out what went wrong in microservice B for that scenario. That can take a time, and you might eventually just find that it was the wrong version deployed, or someone had already modified the environment by playing with it while the automation tests were ran. The fourth one here obviously is managing test data and managing test environments. This actually becomes a thing you have to do. You generally choose to have either more test environments so you can get more throughput at the cost of extra complexity and extra coordination activity to try and get more of these environments going, or you have less of them, in which case you produce these bottlenecks. And those bottlenecks essentially produce these all-at-one painful deployments. What happens is over time, as your teams get bigger and bigger, they're not slowing down. They're still adding more and more changes. But generally speaking, you're not adding more and more test environments to do this. And even if you are, you still need to give yourself confidence that the change you've introduced is not going to break the rest of the system. So you still have to kind of test it all together and coordinate that. And so you only have two choices. You have to introduce one change into the environment, then release that, then bring the next in and into the same fixed environment and release that, or you just deploy everything together. Either way, what you do is you create these build queues where other teams are reliant on each other to release their software, because we need to make sure they all work together. So kind of what happens is, as you add teams and components into the mix over time, what we see is this non-linear relationship with things like, with the cost or complexity of time or number of things like environments, the build time, the risk associated with a particular change, and developer idle time, right? How long developers are idling between things or moving between things and not actually producing feature work. So I'm just going to skip this slide, sorry. So that's a bit of a challenge. Given the size of the audience, I'd normally go out and ask about this, but I think you guys have some idea of this challenge. So I'm just going to assume it is, and we can talk about that in our discussion at the end. But this is kind of where contract testing comes in to try and help us. So contract testing is a way to test microservices independently and help release them safely. That's its main job. So we talk about microservices, but really we're talking about any distributed system. So the use cases are things like JavaScript web applications, so React or Vue or Angular, native mobile apps, Swift or Kotlin or Android, RESTful microservices with JSON XML, or asynchronous messaging. And we'll talk about things like gRPC and whatnot. I can see some great questions about those sorts of things. And the main goal is to reduce, if not remove, some of those end-to-end integration tests. So if we can just at least reduce the scope of them, we're doing really well. And again, we want to try and reduce the reliance and need to frequently use these complex test environments. Again, just trying to use them for their most important purpose. And if we can do that, we can usually speed up the development process, or the testing process, a fair bit. And we can also reduce the cost of that testing process. So what actually is contract testing, and how's it a bit different? So it's still, I would call it, an integration testing technology or approach. What we do is we look at an architecture like what you see here in the diagram, and instead of testing the whole thing at once, what you do is you identify all the boxes and arrows, and you find the arrows between those boxes. And actually, that's what we're going to test. We're going to test the arrows because they represent integration between one or more two systems, usually. And so in this case here, you can see there's 6 boxes. There are 6 contracts we need to capture and test. And what we do is we capture the needs of those systems in an isolated way. We look at, excuse me, go back to that animation. We look at, let's say, for example, it's a React website. Well, it talks to a gateway. Okay, so what is that sending to the gateway, and what does it expect to get back from the gateway? And we can check that in isolation. And in fact, what this lets us do is even look at one side of the integration point in isolation. We can go, what does React website do to this endpoint? What does microservice A need to do? In this case, it's both a consumer of an API and a provider of an API. And by looking at these integration points in isolation and only caring about those integration points rather than the entire system, we get a bunch of benefits. The first one is that it's much simpler. We only have to think about a single integration at a time So as a developer or a tester, you can fit that in your head. You can understand what it is you're looking at. Whereas the entire ecosystem is much harder to fit in your head. And you don't need to deploy it. You can test this locally. Because you can test it locally, you don't need dedicated test environments to do this kind of testing. That means you get really fast, really reliable feedback because it's not happening on some non-deterministic managed environment. It's happening on your laptop, which you can control. The other thing is because we're testing the integration points and not the system, the tests actually scale much more linearly in time. So as you add a new integration into the system, that's just a single increment of number of tests you need to run. Literally is the number of tests you need to run is the number of APIs or integration points you have. Whereas in end-to-end test, when you add a whole new integration into the mix, you're actually multiplying out the number of tests you need to run because you're testing it all together. So now you need to increase the permutations. And lastly, because you're testing things independently, you can deploy them independently because it gives you that confidence around the communication breaking changes. This is kind of where Pactflow comes in as well. So Pactflow is our managed platform around contract testing. There's the open source Pact broker, which is that sort of fluorescent-y pink color at the bottom there. And that is where we basically have our collaboration point. So think of it kind of like GitHub for Git. You've got your Git running locally. That's the open source tool, and you're publishing, pushing your code up to GitHub. Think of the Pact broker a bit like that, where we take the open source Git, but add a whole bunch of commercial features around that. I'll skip past that too. So before we get into how it works, what we see is in terms of results of our customers who we've polled over the years, the impact of adding contract testing into their existing system, we found that basically 1 in 2 have reduced the time they spend maintaining integration tests. Half of them have decreased their lead time. Again, almost half of them could then deploy on demand when they couldn't do that before. About a third have reduced the number of failure rates in production. And equally, about a third have improved their mean time to recovery. Okay, so how does it work? There's kind of 2 modes within Pact and contract testing with Pact that we can talk about. One is our standard where it all began testing, which is your sort of RESTful microservices with HTTP. And the second is asynchronous communication, so things like message queues. We'll talk about both of these very quickly. So let's just get some parlance or language down pat. In this case here, let's say we've got a React website talking to some microservice. Let's say it's in Java. We call the website the consumer and the API provider or service the provider. And then all the messages are passed between them. All those interactions, we call them, form the contract. So for example, the website issues a GET request to /orders/ some ID and expects to get back a 200 and some body. This is our contract in its simplest form. So the way you would write this test, and you'll see a bit of repetition in this talk, but hopefully that helps. If we weren't doing contract testing, you would test this integration point by standing up both the consumer and the provider, running tests between them, and making sure it works. But with contract testing, we never run 2 things together because as soon as you do that, you then have to ask the question, at what point do we draw a boundary to not stand up that system? So we just take the position straight away. You always test each system in isolation. And the contract testing tool, in this case Pact, will act as the mock for the provider, or it will stand in for the consumer and be the client, as you'll see. With Pact, it's a consumer-driven tool, so we start with the consumer side. So what we do is we write a series of tests for this consumer against the Pact mock that's going to pretend to be the provider. And we're going to write a whole bunch of tests that sort of test the API client of this consumer. And what Pact will do is it will check that the consumer makes the correct call to the API and the consumer can handle the response. And we do this for all the interactions from this consumer to that individual provider. Step 2 is to take that file, which we call the contract, and we send it up to Pactflow to store and manage. Step 3 is we'll have the provider then in its own pipeline, separate to the consumer one. When it runs its build, make sure that it doesn't break the contract. So it basically goes to Pactflow and says, hey, Pact, go out to Pactflow, pull down all of my consumers, find all the contracts with them, and then replay them against me. So in this case, Pact is going to act as the consumer, stand in for that consumer, and it's going to issue the request against the provider. And if the provider responds as the consumer needs, we have symmetry on both sides of this integration point. We're feeling confident that they're compatible. So the verifier is going to find all known consumers for that provider. It's going to check that the provider can respond to all of those requests, and it's going to look at all the details of that to make sure the rules like the headers, the body, the status are all correct. Cool. Let's quickly look at the how we do this with messaging. We call this asynchronous pact or message pact. So things like Kafka or SNS, RabbitMQ, Kinesis, these kinds of things are where you would want to test this. So it's a little bit different in the message form of the world. It supports asynchronous, and actually the V4, the latest version of Pact, also supports a synchronous version, a space synchronous version of messages. So gRPC is a good example that spans different types of interactions. It can be one way, pub sub, fire and forget, or it can be request response, and it can also be multiple requests, multiple responses. It gets a bit more complicated, but all these things are very testable with the contract testing mechanism. So in terms of this hypothetical situation, we have a Java order management component, which is publishing product updates onto a queue through Kafka, and we've got a Golang consumer. So similarly, we still have a consumer. It's going to receive the message off the queue, and we're going to have a provider which is going to put that message on that queue. So in messaging parlance, often that's called a message producer. And then the contract that gets put between them is some metadata. In this case, with Kafka, for example, you can put a topic in there, and then you've also got the body that goes onto that message. In this case, it's JSON. That's our contract. So Message Pact is a little bit different. Message Pact has, similarly, it's a bit simpler to look at because it's only kind of one way. We don't get a response. So with the consumer side, what we're doing here is we're saying we expect to receive a message from a provider. But what Pact actually does is, because there are so many different types of queuing implementations, we just listed a few before, but there's literally hundreds if not thousands of these things. So we don't have adapters for every single one like Lambda, SNS, Kinesis, RabbitMQ, Kafka, so on. We take a higher level abstract view of this. What we really care about is the payload that goes on it, because there's plenty of tools to test those tooling specific things, to check Kafka or to check Kinesis, what have you. One is you can probably assume that there's really robust libraries that already deal with this product. And two, the thing that's more likely to break is actually the message gets passed between. So in this case, what we do is we just give the message as you expected off the queue directly to the consumer to ingest. And what we do is Pact will check if it can invoke the correct message handler, and if the handler can indeed just process the event. Similarly, we do that for all the things this consumer can do. We upload the contract to Pactflow. And in the provider's build, when it changes, similarly, we're not going to, we need something that starts this whole process off, right? What's the process that kicks off a producer to spit out a message somewhere? So you need a hook into the code here to do this. And so Pact expects it to be a hook to be able to invoke some function, and then Pact will just invoke that function. It usually uses a message key, which we can talk about later, that would trigger that function. And then, of course, once the function is invoked, it would do its normal provider logic, produce the event, and then Pact would check that event looks correct. So again, we're just going to make sure the correct function will produce a message, and that message is correct, just like Pact with HTTP. Okay, so here's where we get to look at a demo. Now, I'll just quickly remind everybody, I'm not sure if I heard it before from Nan, but I believe we're taking questions here through Slido, so do feel free to vote and add questions to them. We'll definitely get to that hopefully in about 10 minutes. So we should have 20 minutes approximately of time for Q&A. All right, so our use case today, we're going to look at a React product catalog website that's going to talk to an API, product API, to get products and display them on a web page. And we're going to look at the consumer flow, the provider flow, and we're also going to look at, how do we introduce a new change, and how do we detect breaking changes. So here's a little use case. And I realize I've got the wrong logo there. It should be JavaScript talking to JavaScript. So we have a React JavaScript thing talking to a JavaScript product API. Simple as that, JSON HTTP. Let's have a little look at the code base. We'll start with the provider, then we'll work our way to the consumer, and then we'll write the test from there. So on our provider side, it's pretty straightforward. We have, some routes. We have two routes, one that gets all products, one that gets a product by its ID. You'll note there's a little difference here. This is pluralized and this one's not. And we might play with that a little bit later to see how we can break things or fix things. We have a product definition. It has the ID, the type, and the version. It also should have the name there, but I'm currently in the wrong branch, but you get the idea. And then we have controllers that deal with that. We have in-memory repository. In real life, we talk to a real database, but just to keep this demo simple and fast, it's just an in-memory implementation of a database. Over here in the consumer code base, we similarly have a product definition. It needs ID, name, and type. So as you saw there, it's actually missing a field because I have the wrong branch in my provider setup. But this is all the consumer needs. It only needs these three properties. In fact, I'll just quickly go back to make that clearer. Just going to go back into the master branch in the provider. And we should see that it actually has four fields. There you go. ID, type, name, and version. This is the provider code base. But over in the consumer code base, it's not using version, right? It's just got these three properties. We have an API class over here that's responsible for actually calling out this API, get product and get all products. This is just pure JavaScript. It doesn't have anything to do with React, even though this is a React code base. And then lastly, we actually have our product page over here, which is going to render the product. This is quite an old React code base, so it still uses these old lifecycle hooks, but the process is the same no matter what hooks we're talking about. And it's also very similar if using Angular or Vue or whatever have you. The main thing is when this page goes to load, this function will kick off as part of the hook and go, cool, render the page, please. Go out and get some data to populate for this page. And so when the page goes to load, it calls the API, gets the API class, it calls the get product method using the ID of the product we're trying to look at. And then once data comes back, it sets the state. That will trigger a render of this div, and then the product will get rendered on the page. So not very interesting, but enough to take us through this whole process. Okay, so let's write our consumer test on this side. Now that you've seen our React code base, as we talked about, this is actually the thing that's making the API call. So in a Pact test, which is very much a developer test, and I should mention this because I didn't I think, iterate that before. If it wasn't clear throughout those slides before, contract tests, particularly using Pact, very much are a developer testing tool. And the reason for it, you'll be able to see now, is very clear. We're going to be unit testing this particular function. So to write a contract test, the best way to think of that with Pact is that we're writing a series of unit tests or something close to a unit test of our API client. And so to do that, we're going to need access to the code. And that just means that it's a bit harder for certain roles within a company to write those tests if you don't have access to the code. So right here, rather than test this React code base from the outside, where it's a much more high level test and it's testing lots of layers, we want to get as low as we can just to check what this function here does, and specifically what this bit does. So as we said, if we drill into this function, this is a little bit simpler to test. It makes a call to this endpoint. It needs some headers. It turns data back into a product function definition, and that creates a product. So if we drill into our Pact spec, you can see over here, we've got a standard kind of arrange, act, and assert model. And I'm just going to remove that just to bring it all into the same frame. So the scenario here is we're retrieving we're retrieving a product given that the product with ID 10 exists. So to run this test, as I said, we're going to write a unit test for our API client. So the first thing we're going to do is to set up some mocks. So if you're using some other mocks, this should be fairly easy to translate across to Pact. We're just putting it in a Pact specific way. Pact also takes a BDD style definition to help give you some free documentation about how your consumer is actually using the provider. So in this case, the state is that a product with ID 10 exists. We're going to make a call to get a product using the get verb at this path with some headers, and we expect to get back a 200 with some headers and a body that looks like this expected product. So it's got an ID, a type, a name. That's the arrange. We now act. So we set up an API class. We construct it. We give it the URL of the mock service rather than the real thing, because we need to talk to Pact, not the real world. We then run the command, get product 10, and then we check. Did the response come back from this equal what we would expect? So everything from here down is the same, really from here down, is the same as a usual unit test. We just happen to be using Pact to mock out the back end rather than something else. At the end of this, we should have a contract that says, has this interaction encapsulated in it. So we know the provider now needs to better do this for this function to work. So let's run the test locally, see what happens. What I'm also going to do is, because this project has been built before, I'm going to kick off a build so you can see what it would look like in a pipeline. Excuse me. So we'll go to our GitHub build. Going to kick off a master branch. So this will produce this will run through a new CI pipeline, and I'll show what those steps are in just a moment. There you go. So we go back to my terminal. We should see, a few tests have run. There's 3 tests. There's a few others in that file that I didn't show you. But specifically, given that ID 10 exists, that one there was what we just ran. If we come in here and look at within our packs directory, we should now see a contract file has been produced that has those interactions in it. So we've actually got 3, but the first one here is the one we just tested. Product with 10 exists, get at this path, blah, 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 blah. So you don't really need to look inside the contract file. This is really implementation detail. Think of it a bit like a Java class file. It's important, but you don't really look at it day to day. But it has all the information about what we're expecting this consumer to be able to do and what we need the provider to do for us to work. All right. So this job is now kicking off. Let me show you what it's about to do. So we've now written our consumer test that's going to test the API client. We're now going to push this into our pipeline and watch it run. And so what's happening here is going to first run the tests, right? And then it's going to then publish the contract. So once the tests have run, it publishes the contract up to Pactflow. We then run can I deploy? It's like, is it safe to deploy this piece of software to production, for example? That should be no. That should be a failure because this is brand new. There is no provider yet. We're doing this whole consumer-driven thing. So it's not safe to release this because if we push it out, it's not going to work. We haven't seen a provider verify this change. So that's what we should see in our pipeline just now. Okay. That's interesting. It's interesting. It says Pactflow example provided here. So I'm just wondering if there's some some configuration in a build file that's got it hasn't been copy pasted properly. But anyway, the test passed, which is what you'd expect, right? We saw those tests pass. It's a unit test. It should pretty much always pass. But this can I deploy step should actually fail because it won't be safe. There we go. To deploy that. And it says, I'll zoom in a little bit. Here it is here. It says there is no verified pact between this version of the consumer and the provider. And you'll see in brackets somewhere it should say no version exists. We've never verified it, so it's not safe to deploy this thing. Simple as that. So we now need to go to the provider code base and implement the feature. So let's do that. Okay, swapping into our provider code base here. I've showed you around it a little bit. What we're going to do now is we're going to write our provider side pact test. What this is going to do, and I'll walk you through this. It's going to go out to Pactflow. It's going to pull the contract down based on some selection criteria, which we won't get into today. But it's going to find all the consumers, find the pact to verify, and then Pact will reissue all the requests in that pact file against the locally running provider to make sure it conforms to that contract. So what these lines here do, this is basically standing up the provider locally on port 8080. This is where you would start your own provider and make sure that you set it in a mocked context. So if you've got Spring, you'd use annotations to put in mocks. In JavaScript, you can use your standard mocking tools here as well. what all these properties basically do are these are all just configuration toggles for how to go and find the packed file, which types of files we care about. We've also got lots of bells and whistles on this one because it's used within a workshop. But basically what it boils down to is this is where the provider is running. This is the current version of it to send that information to Pactflow so I can see what's going on. And down here it says this is the name of the provider, how you can go and find other consumers of it in Pactflow. And this is the URL to go and find them from Pactflow. And then there's some tokens that get sourced into the environment. That's all it is. It goes out to Pactflow with those configs, pull down the contract, and it runs it. And then this step here literally just runs the verifier. That's it. So if I run, again, similarly here, if I run the test sequence, it should pull that contract down, run it against that locally running provider. So let's have a look at that. What I'm also going to do is I'm going to kick off a provider build in GitHub as well, so you can see that workflow go. And what's going to happen? We're going to run those tests locally. It's going to pull the contracts down from Pactflow, run those tests. Hopefully that passes, and then we're feeling confident that our provider's good. We're going to publish the results of that back to Pactflow. And the idea here is Pactflow is building up this big matrix of consumers and providers and what versions have been deployed to what environment. And it builds up this matrix that says, it knows now what components are compatible and in what environment, and is it safe to release those pieces of software to those environments. Now, in this case, because the consumer hasn't been deployed, totally safe to deploy the provider to an environment because it can't break anybody. And so the can I deploy should pass, and the deployment should pass as well. So let's have a look at my command line. There we go. The local test passed. So I pull the contract down locally. I'm getting local confidence. This is good. So now I can push my code up and run that build that I just kicked off in the background for you. You can see it run all these assertions. Apologies, I've got some verbose logging on here. So you've got some intertwined output, but you can see that it ran the test. They all passed. 3 interactions, 0 failures. If I go into GitHub and just refresh this build, there we go. The test phase passed. Can I deploy fast? And now it's going to deploy this to production. Now it's not a real deployment, so it's just going to pretend like it's doing that, but it's going to let Pactflow know it did it. And what that means, here we go. So now, as you can see here, we've got a contract in Pactflow, which is what we just set up. This is the Pactflow's UI's version of it. You can see we could publish the consumer just a few minutes ago, some version in master. It just verified that a few minutes ago too. And if I refresh this, or you can see actually it's already been deployed to production, but the consumer has not yet been deployed to production. There's this matrix of information here that's showing things have been verified. Again, it's just this is going to get bigger and bigger as you spend more and more time building and modifying your software. We've just started this, so we've got one row, but as we modify our consumer and provider, this table will build out so you can get a visibility into which versions of which things are compatible with one another. All right. So that's what we just did. We ran the test, we published the verification results, we checked if it was safe to release, and we released it to production. So now we need to go back to our consumer because we didn't deploy that before. The consumer is still waiting to be deployed. So we can simply go back to our consumer now and just rerun this whole job. Just rerun the failed job, which will just be step 2 because the step 1 doesn't need a change. So hopefully that won't take too long to kick off. As we said, the test phase was good. So it's just going to run can I deploy now, which shouldn't take too long. We use Docker to kick off these commands. And we'll give that a second to run. Hopefully it's not going to take too long. There we go. Pulling the container. Running can I deploy. There we go. Can I deploy passed. It was safe. And now we're going to deploy this piece of software. So it's going to kick off the deploy step, which will again use one of our CLI tools as a Docker container, and it will deploy the software to production. And then once that's run, we'll actually see that this will have been deployed to production, and then we can continue to evolve the whole thing. So there we go. Okay, recorded deployment. Let's refresh that. We'll now see that we have the consumer and the provider in production. Awesome. One more thing, and then it's time for questions. So what happens if we change our provider, check out demo, I think it is. What if we change our provider to remove a property? In this case, we're going to remove the name property, which we know our consumer uses. Well, if we do that, we can do a few things. If I run test locally, we should be able to find out on my laptop that this will break that consumer we just saw, because we know now the consumer needs that field, and that we should make sure we deal with it. So there you go. The test failed. You can see there that it was missing. It basically says it's a diff. We're missing a name property. There should be a string. So, oops, we better not do that. So let's go back to master. Yeah, check out master. Similarly though, and I want to show you this thing because I think this is cool. So before we commented that one out, but let's comment out version, which we know the consumer's not using because we showed that before. If I run that locally, despite that technically being a backwards incompatible change as far as the provider is concerned, what we know is the consumer doesn't use it, or there's no consumers using that property. So actually doing that is a completely safe operation. And as you can see, our test has passed. You know, it's not concerned about that. And that really helps us as we have a provider API. That it just helps us avoid this sprawl where you can never, ever remove properties from a provider because you're worried about it's going to break somebody. We don't have to worry about that. We don't have to worry about versioning the API now to have another version of it because we want to remove something. And now we have to manage 10 versions. So it's a really nice property of contract testing and Pact that gives us field level, security or safety. Okay, so as we said, what we just did then is we just rerun that consumer test now that the provider's in production, that pipeline, sorry, run the same steps again, run the test, publish the contract, can I deploy? We've now deployed to production because there is a provider in production that satisfies our contract. Okay, I'm 2 minutes behind where I was hoping to be, but I'll blame that 2 minutes at the start of the talk. So hopefully that was really helpful. Hopefully you got some sense of what contract testing is, what problems it can solve, or at least a good taste for it. If you have any further questions or you want to reach out, all my details are here. Get me on Twitter, hit me up at SmartBear, email address, or you can just drop an email, hello@pactflow.io, and someone will reach out to you. And now I'd love to get to some questions.
Thank you, Matt. That's really an excellent overview of the Pact framework and also a great demo to show us the overall picture of the things. Time for some questions. We'll go by the most popular ones. The first one was my question. Oh, now it has gone down to two. Okay, so the first question we have is, what's your opinion about the belief of Pact contract testing is just schema testing? Which schema test can be covered under the integration test?
Yeah. We get a little bit. So I think I've got an article here. Schemas are not contracts. There we go. So worth having a look at. Something I penned a year or so ago that just kind of talks through the differences. So there's nothing wrong with schema testing, and in fact, you would argue that a lot of what Pact does is schema testing. But one of the big differences is that schemas are very abstract, and contracts are more concrete. That's the kind of saying that I have for it, right? And my colleague had a good example of this, but basically, if you think about an OAS, for example, you can have polymorphic payloads in there, and it's easy to miss certain paths. For example, you don't know, given this input, which of the 400 responses, which of the things will produce a 400 response or a 200 response. And OAS won't tell you that in advance. It can tell you what the schema is, but it won't tell you which optional attributes in that schema need to be combined together to give that output. They have these really great benefits in some ways, but because they are abstract, there's certain scenarios that can slip through that cracked. That's the first one. So for example, not all things capture all the parts of a contract. So if you are just looking at a schema, so the body, what about all the HTTP level semantics like the verbs, the path, the status, and these things? So you need a process for that as well. The third one is around visibility into the consumer usage itself. So again, a schema comparison won't tell the provider what endpoints the consumer is using. So you need to build that in yourself. whereas contract testing gives you that for free. As part of those, I shouldn't say for free, I suppose you've got to write those tests, but then the provider can get visibility about what the consumers are actually doing with that API. And now you've got visibility over the API surface area that you actually need to support, as opposed to the theoretical surface area. That because as soon as you release something, if you don't know what your consumers are doing, you have to assume they're using all of it. Otherwise, if you remove something, you could break it. And the last one is really probably around evolution. So in my view, contract testing, and if you go back to the original definition of sort of consumer-driven contracts from Ian Robinson at ThoughtWorks, he talks about this dimension of time. A contract is going to change over time. So a schema is also going to change over time. And just think about your software delivery cycle. You need to evolve that software. And contract testing isn't just a single snapshot in time of a schema. It's a longitudinal view of changes of all these applications, and it can work out the intersections of those. So you need to be able to also encapsulate evolution into that. As we just saw before, it's not enough to know what schema is in master. You need to know what's in production as well when you're about to deploy. What is the target schema? So all that information you need to bring together. If you can do that, we would call that contract testing. Hopefully that answers the question.
Yeah. So moving on to the next one. I think this is one of the very popular question here is, I have realized that it is really tricky to get buy-ins from all the teams, even if we present the right set of data to the Pact contract testing. What's your opinion on that?
Yeah, so I think there's, if I can ask about the question, my guess would be that you're talking, when you say right set of data for Pact contract testing, I think you more mean you can get it set up in advance, the code. Maybe it's more around the socio-technical things. Should we do contract testing? What's the value of doing contract testing? To that, I would say, you can't ever force anybody to do something that they're not convinced about, or at least it's harder to do that. So the companies that do it the best, in my view, have mature teams who are running it. They have champions internally who can advocate for the use of that tool, not just contract testing, but any tool for that matter. They can articulate the value in it, and they can show what good looks like. And any tool, and any tool has its challenges and has its positives and pros and cons, and we're aware of some of the things that make Pact hard to use, and we're obviously trying to work on those. But the reality is you need to weigh it up and go, okay, for the cost of what we get with Pact, what are the benefits I get, or with contract testing? And as a group, you need to make a decision. These are the tools and practices and frameworks we're going to use that are going to solve our problems, and be willing to accept the certain trade-offs that come with that. Developer experience is obviously very important. And if the developers are finding it hard to use any tool, that for that matter, hard to use, and it makes their life harder, despite it providing some value, that's usually going to be a very difficult sell. So, making sure there's good practices around it, there's good documentation internally about how it's being applied internally at, for example, Agoda, they're usually really good starting points to make a thing successful. But ultimately, developers, as rational as we think we are, we're not always rational. We can also be emotional, and sometimes that factors in too.
Yeah, that's a great insight. Thanks, Matt. Next question is from Eugene. Hi, Matt. Thanks for the session. Please share what your customers said about maintaining Pact for the cases when you have hundreds of versions to maintain. Use case mobile API with compatible releases and obsolete clients.
Yeah. So when you say hundreds of versions, I think that use case there makes sense. Hopefully you don't have hundreds of versions of your mobile app out there, but certainly that's one of the strengths of Pact, right, is that it can maintain the relationships of that. So for example, with deployment, you can actually mark 10 or 20 mobile clients, or however many you really want, to say they're currently deployed to production, released to production, but they're all in production at the same time. Usually with microservices, you're deploying one over the top of the other. So version A was out there and it's replaced by B, and that's replaced by C, and so on. With mobile, you deploy one, then you deploy two, and they're all out there, and often they're all running at once. That's a really great use case for Pact, because now you can track those different needs against what the API is trying to deploy. So a good example of a customer I had was it was a payments API, and they had an Android app and an Apple one, and they deployed a few versions. But the actual API itself had Android-specific fields in it and Apple-specific fields in it, and the API had to roll back once, and that broke one particular version of the mobile application. And in this case, they didn't have Pact in place because they were still looking to do that. This was a trigger to get Pact in there in the end because it would have caught that exact scenario. To talk about the scale of that, so there's probably a separate number in terms of hundreds of clients or hundreds of versions. Pact will definitely scale to thousands and thousands of versions. If you have thousands and thousands of consumers of an API, that's probably a different story altogether, which maybe we can talk about if that's a question. But I think you're talking about the mobile client, so hopefully that helps.
All right. The next question is from Metas. Is it possible to do the pack test with more than one provider, like consumer to provider to provider? Reason being, some of our services don't have business logic. For example, client, middle API, and the provider API.
Yeah, so the short answer is yes. I think the assumption here is, I don't know if it's Metas, feel free to clear this in the chat there, but my guess is that maybe I'll bring this up here so I don't have to look down there. If you're trying to skip in this particular view the provider to get to some other provider, then no. But definitely in Pact, you can definitely have chains of API calls, A to B to C to D to E. Absolutely no worries. A application can have the role consumer and or the role provider. So it can be both at the same time. Hope that answers your question, but do feel free to drop a question in the chat there and I'll try and answer.
Okay, so I'm the one who asked the question. So why I asked because most of our client we talk with a gateway API which itself doesn't have business logic, and whenever we want to write a pack test to it, we don't get much benefit from testing a service that doesn't have business logic. Even we have some kind of contract restricting the client, but if the provider itself doesn't check anything, in production it doesn't do anything. So the actual business logic is in another service which gateway API talk to. So that's why I'm wondering if we could have like one, maybe say pipeline, where whenever a consumer pipeline is a trigger, it go and trigger the gateway provider, which gateway provider itself go and trigger other service which has business logic. I hope that.
I mean, you can probably try that. As far as Pact is concerned, it especially if that API doesn't have business logic, but it does do something different. If it's just pass through literally, then you can probably just skip it altogether. So often cases, an API gateway, for example, falls into this class where all it's really doing is routing. And sometimes doesn't even do that, just passes straight through and it adds authentication or something. In those cases, I would skip that as far as contract testing is concerned. But in your case, if it's an actual API written with code, then it probably has more than just that, but maybe less than a more fully fledged provider. So in those cases, it's a bit hard because you still have the contract is really the message that goes between them, right? It doesn't really care if there's business logic or not. It's more around the shapes of the messages and can they be understood and so on. So you still need to capture that. Pactflow does have a feature we call that bidirectional contract testing, which allows you to do more of a schema type check in the contract testing. So if you think about contract testing as that general concept I talked about earlier about the different checks and balances, the evolution, tracking its consumers, all these things, and then different ways to do the actual check. Pact is one way; it's a record and replay way. Bidirectional is more of a static schema check, and so that might be applicable in these situations because it's a bit easier to implement as a provider that doesn't have any business logic. Hope that helps.
Okay. All right, so the next question is from Alexander. For REST services, we widely use OpenAPI. Can we have an advantage of mixing OpenAPI with Pact? How it could work?
Yeah, great question. So I'm just taking a photocopy of that one so I don't forget. I'll definitely follow that one up. When you say mixing, you're talking about extensions to the OpenAPI spec? And maybe feel free to jump in, Alexander, if you wanted to elaborate on that.
Yeah, actually, my question is, if we use OpenAPI, how we can take an advantage within Pact? So maybe we can build Pact over OpenAPI or in some different way. So what possibilities we have Pact?
Yeah, with Pact, we haven't got any integrations with OpenAPI. I think there's been various community attempts to make those work, but we feel like every time we do it, it feels like it's taking Pact too far away from its core. So OpenAPI definitely has its benefits and really important parts of the community, and obviously, it's SmartBear as well. Swagger is and OpenAPI is a really important technology as well. As I said earlier, the way we've approached that is through Pactflow, through our bidirectional contract testing feature, which works with OpenAPI. And we think that's probably the approach we'll take, at least in the near term, to help solve that problem. I can send you a link there if that's going to be helpful. But of course, if there's different approaches, we're obviously always keen to hear. One of the things a lot of people ask is, I've got an open API. Can I generate my Pact test from that? And we've got a Q&A on our blog, on our docs that talks to that problem. The answer is no, or the answer is you can do it, but it's not going to give you any value, because just because you've got the Open API spec doesn't mean that you automatically know what the consumer is actually doing with that Open API spec. So we make it sort of analogy. It's like it's marking your own exam, because you don't know, yes, this API has all these endpoints, but is a consumer using all of them, or is it just using a subset? And then following on from that, is it using all of the API fields or just some of those as well? We don't get that visibility if we do it that way. So OpenAPI has its place, but not in this particular scenario that we've been able to think about too deeply. But yeah, happy to chat further on Slack or somewhere else. It's definitely an area that we do get a lot of questions on, and we're always thinking of how to make it better.
Okay, for the interest of the time, Matt, the last question, and that's one is from me. What is the advantage of using Pact and CDC with data serialization formats like protobuf that has forward-backward compatibility?
Yeah, great question. This blog article is not far off explaining the same problem. I do have another one that talks specifically to gRPC and protobufs. I think it is there. There we go. Very similarly, if you just scratch under the hood for 2 minutes, you'll find there are plenty of ways you can make protobufs, Avro, Thrift, GraphQL break. And so, yes, they're forwards and backwards compatible, but it also comes with a gigantic star next to it. So, I think it's been a while since I've looked at the details here, but there's a whole bunch of areas that actually can quickly fall apart. So the breaking change, for example, I've forgotten the exact specifics, but with message semantics, there's ways you can impact those by changing for example, the fields of the order fields, or if you change the types of them. There's a whole bunch of ways you can actually make them backwards incompatible just at the protobuf level itself, let alone the evolution of things, for example. So a good example, I think I might have talked about it here. Let me just jump down. There was I think it's optionals, or it might have been the default fields, actually. We had a customer at DS, the company that I worked for previously, consulting client, a very well-known global payment company. They used protobufs. And what happened is that the new field was added to the provider that was mandatory, or was optional, sorry. I guess they're always optional. And previous clients were still using it, obviously, to provide that forward compatibility. It turns out that's only wire compatibility, not functional compatibility. And what happened was those fields have a default value of true or false. In this case, it was about enabling or disabling a merchant. And because the consumer didn't know about this field yet and was talking to this API, that field got defaulted to false. And so what happened was every time that consumer made a call to the provider, the merchant provider, it disabled the merchant. In fact, I think what it did was disabled payments for the merchant. So they weren't actually getting remittances. So it's a good example of, yes, it's wire compatible, backwards compatible, but that doesn't mean it's semantically useful. And so in this case here, had you have had a contract test in place, you would know that this consumer really needs that, or this provider really needs that property, or vice versa, and that was going to cause some problems. So hopefully that gives you a bit of an idea.
Yeah, thanks a lot, Matt. That's all from my end. Over to you, Nan. Nan, you are on mute.
Okay, sorry. Matt and Abby, that was a great session. Thank you so much. We really appreciate you taking the time to share your insights and your thoughts with Agoda. Thank you. And
You're
thank you
welcome.
everyone for joining the session. We really appreciate your time, but please, before you leave, please take some time to share your feedback in the form I just shared in the chat box. Thank you and hope to see you guys in our next Tech Talk. Have a good day.